Good day, students. Today we're going to look at another max-min problem. It's in your textbook. It's in book 2 in practice 4. It's page 98, number 4. 98, number 4. And we're asked to find two numbers whose product has a minimum value, but they have a difference of 8. Now, what does all that mean? Well, first of all, this problem could be done without using a quadratic equation, but we're asked in a previous instruction to set up a quadratic equation to do this, okay? So, I mean, you could take any two numbers that differ by 8 and find their product. Differ means they, right? Like, for example, 8 and 0 differ by 8, right? They have a difference of 8, so 8 minus 0 is 8. So there's two numbers that have a difference of 8. And their product, if we looked at their product of course would be multiply the two numbers, and that would be 0 times 8 is 0. Now 9 and 1 also differ by 8. Remember, difference means subtract, so 9 minus 1 is 8. So 9 and 1 differ by 8. Remember, 8 minus 0 differ by 8. Right, so these numbers have a difference of 8. But if I multiply 9 times 1, I get 9. So my product is getting larger, not smaller. I'm looking for a minimum product, right? So that's not making sense, is it? Now, if I keep going up with the numbers, for example, if I go to the next one, which would be 10 and 2, they would differ by 8. If I multiply them to get their product, that would be 20. Look, our numbers are getting larger. So this is not going anywhere to solve our problem, is it? Now, if I started to say, well, let's try some negative numbers that differ by 8. Now, I would say, therefore, well, 7 and what multiplied by what? Oh, that would be negative 1, wouldn't it? They would differ by 8. Remember now, 7 minus a minus 1 is 7 plus 1, which is 8. So those two numbers differ. Differ means subtract, difference, by 8, right? So when we look at those numbers, we say, well, 7 times negative 1, that's negative 7. 6 times negative 2, well, negative 12. Look, our numbers are getting smaller, aren't they? So we're heading towards a minimum. They're actually getting smaller. The product is getting smaller each time. 5 times negative 3, they differ by 8. 5 and negative 3, that'll be negative 15. 4, sorry, I've gone the wrong way. This would be 4 times negative 4. That would be negative 16. Now if we see the pattern there now, 7, 6, 5, 4. See, 7, 6, 5, 4. This would be 3. Negative 1, negative 2, negative 3, negative 4. This would be negative 5. They would differ by 8, right? Just check. 3, subtract 5. Right, and negative 5. See what happens? That becomes 3 plus 5, so they differ by 8 units. Alright, so what's the product of 3 times negative 5? Well, that's negative 15. Or I could go to 2, and if I went to 2 times, what will be the next one? Negative, oh, now look, it's getting greater again. So it went up to 16. And now it's going back down, isn't it? Or getting higher, isn't it? Negative 15, 12. So it looks like the two numbers that give us a lowest product or minimum product would be 4 and negative 4. And the product would be negative 16. Now there's a solution done with what? How are we doing it? We're doing it by logic, right? And we're guessing and checking answers. However, that's not how we're asked to do it, is it? We're asked to do it using a quadratic equation. Now, how do we do that? Alright, let's set it up so we find a quadratic equation, then find the numbers. Okay, so how do we find that quadratic equation? Well, we know the two numbers. Now we got to use some variables for our two numbers, so let's use x and y. Let's call our two numbers x and y, okay? They're the most common used variables, x and y. Now they have a difference of 8. So dragging those two pieces of information together, two numbers have a difference of 8. We don't know the two numbers. We're calling them x and y, but they differ by 8. So it's not too difficult to come up with that equation. Now, is that what we're asked to? Are we asked to minimize the difference? No, we're asked to minimize the product. We want the product that's a minimum. This is a difference equation. So when you're doing this, you're going to set up a difference, or it could be a sum, right? So this is our difference equation. Now I'll just draw a little line over here. Over here is our product equation. Okay? So we're going to have a difference equation and a product equation. Now what's our product equation? The product, well, we have no variable for that. So let's call it capital P for product. The product of two numbers is a minimum. Now what's our two numbers? X and Y. And product means to multiply. So it's just X times Y. Now some people put it in brackets, some people, I just write it together like that. P equals XY. And when you write it together like that, it's understood to be times in the middle, right? So there's our two equations. So that information above gives us two equations. It gives us a difference equation, gives us a product equation. Now, we want to minimize, or want the minimum of which one? Do we want the minimum of the difference or the product? We want the difference of the product, or minimize the product, don't we? We want to minimize the product. That's the one we're asked to find the minimum of. So this is the one we have to work with. Now, as you notice, we have two variables, right? And we don't want two variables, do we? What do we want? Okay, we want one variable, so we can work with this. So how do we do it? We use the other equation to substitute in. So we're going to use, okay, the difference equation and substitute it into the product, so we end up with 1. Now which one do we solve for? Do we solve for this x, or do we solve for this y? What do you think? I would solve for the x because it has no minus sign. So I'd bring the y to this side, add y to both sides, right? So x equals 8 plus y, or y plus 8, whatever way you want to put it. Now take this and substitute it into the other equation for x, because we're asked to work with the product. The one you set that has a minimum or maximum attached to it, that's the one you have to work with. The product is a minimum, so we have to work with the product equation. So we're going to put 8 plus y in for x times y that's already there. So we have a distributive property, right? 8 times y is 8y. Y times y is y squared. Now we're used to having a squared term in front, so I do one more step. You don't have to do this step, but I like to have my squared term first. Now look at that. Does that look familiar? Yeah, there's your quadratic equation. We just set up a quadratic equation. So there's your quadratic. Alright? Now how do I know it's a quadratic? Again, you should recognize it. Remember, a quadratic is y equals ax squared plus bx plus c. Right? This time y is the product, and we're using y for the x variable in this case. There's now c. Where's the c value? Well, there's no c value, so it's really plus 0, isn't it? Alright, so as you can see, that's our quadratic equation. Let's get rid of that. Alright, so we have our quadratic. Now, what do we do? Well, now you're back to what we did in a previous video. Once you have the quadratic equation, okay, then what do? Well, you take the quadratic and to find a minimum of this product, we're going to use what? Minus b over 2a. And minus b over 2a in this case is, now it's y, what the x, whatever the squared term is this in this case, right? So it's y, and it's minus b, which is 8 over 2 times 1. A is 1. See how I got a, right? A is understood to be 1 right there. B is 8. So I get negative 8 over positive 2, which is negative 4. Now remember, one of the solutions we got, one of the numbers is negative 4. Right? What's the other number? Well, the other number is, of course, what? Well, we know it's positive 4, but how do we get it? Take that value and substitute it right back in there. So the other value is 8 plus y, which is 8 plus negative 4. The other number must be Whoops, it must be 4. So your two numbers, right? So the answer is two numbers are 4 and negative 4. And the minimum product is negative 16. There's your complete answer for number 4 on page 98. The next video now will deal with number 6 on page 99 if you want to watch that one.